Okay, so I'm going to talk about operations without the operating system. The title will hopefully make more sense at the end of the talk than it might do to people now. I'm Gareth Rushgrove. I'm Gareth R pretty much everywhere on the internet. I work at Puppet Labs. But like most of the other people who've been like vendors talking, I'm not really talking about Puppet and Puppet Labs. But if people do want to talk about that afterwards, come find me. First, some quotes. So, hopefully these sound sort of familiar. These systems had never been designed with security in mind, and now we're becoming hugely complex. Anyone feel that represents their job at the moment? Some people saying yes, I'll take that. The dense complexity and increasing length of computer code as computers were asked to do more and more would make malicious code increasingly hard to find. Again, sounding familiar? That was written in last year, and everyone's just gone, someone's reading a blog post about Heartbleed, and it wasn't about Heartbleed, or any of the other myriad of security vulnerabilities last year. It was in a history book about the 1970s. So I'll come back to why that's important, relevant, and interesting, at least to me, later on. But yeah, remember that. So this talk is mainly going to be about sort of this explosion of sort of new operating systems that have appeared in the last year or so. There's sort of also some rabid speculation, really around the age of the general purpose operating system is over. It's done. It's gone. We should move on. And I'm going to lead on from that sort of rabid speculation to sort of, well, what does that mean? What will that mean for operators? What will it mean for people who run these systems like us? So not everyone will be reading all the bits of the internet where people are talking about new operating systems. So I thought I'd do a bit of an introduction to some of the things that are happening. Before I do that, I'll get some audience participation going. So what server operating systems are people running? Shout out. Ubuntu, CentOS, Red Hat, RHEL 6, iOS, good correct answer. Any others? Solaris. Windows, anyone? So I'm guessing most people said one of these or thought one of these. I definitely heard all of these, although I said the Windows one. And some people were definitely going to try and be clever, or are clever, depending on your viewpoint on this. It's sort of and say, yeah, Solaris and BSD. Someone in the room is hiding the fact they're running AIX. Sometimes someone will own up, not always. You'd be massively surprised about how many organizations are still running lots and lots and lots of AIX. Tom May's in the room, he'll be nodding at me as well. Elsewhere on the internet, there are lots of things happening. And I think there's always been sort of new bits and pieces coming along and sort of smaller Linuxes and all sorts of things. But actually, over the last year or so, lots of these projects have sort of coalesced, or larger organizations have done more things with them, or everyone has shiny logos, which makes slides easier. So this isn't really a talk about any of these projects in particular. I'm not going to do demos on any of these things. They're all sort of interesting in different ways. Some of them will succeed, some of them will die. But knowing that there's a whole bunch of them is sort of interesting. So Project Atomic from Red Hat is sort of interesting around sort of just, I think it's one of the things where it's really focused on atomic changes to the entire system at once. So you're not updating this package and changing this file. You're updating the entire thing in an atomic way. That's sort of interesting. More people have heard of CoreOS, which is really sort of focused on being an operating system for clusters. It's yes, it's running on a machine, but actually everything is geared towards you running many of them. Running a single CoreOS machine feels pointless. Snappy from Ubuntu is sort of interesting, and replacing sort of package management with containers as a sort of primitive. That sort of comes up a bit. RancherOS is sort of Docker all the way down, which is sort of interesting, sort of crazy. Windows Server 2016 shipping with the Nano stuff is actually really, really good. Or will be when it exists. We're shipping 2016. No, actually, Windows 2016 is meant to ship in 2016. VMware have been doing the Bonneville stuff. Again, this is sort of, I guess, prototypey stuff. And definitely, I can't imagine them shipping a product called Bonneville, but it's a code name, and there's some code out there. And this is really actually combining, something VMware do quite well is virtualization with containers, getting sort of isolation there. Intel are doing some of the same stuff around demonstrating hardware isolation guarantees for containers using the Clear Linux stuff that they've been playing around with. So there's a whole bunch of these projects. I mean, some of them are coming out of big companies, some of them are startups that people are putting money into. There's sort of something happening, there's something interesting. And there's a bunch of common themes that sort of come up around these sorts of new types of operating systems. They tend to be cluster-centric. They tend to be assuming that you're going to be running lots of them. So a lot of the things that we take our existing operating systems to do and then add things on top to deal with sort of them communicating with each other, them knowing things about each other, whether that's configuration management tools, whether that's service discovery tools like console and etcd. They tend to be getting pushed down to the operating system as just primitives that we can use. Because no one really wants to run a Zookeeper cluster. Zookeeper's amazing, but no one wants to run one. Read-only file systems are a common theme here as well. Again, lots of people talk about immutable infrastructure, and I often go oh, so what's your read-only file system of choice? And they're like, what? The fact that people should be doing it doesn't mean anyone is. The nice thing is that it's getting baked in the operating systems. We shouldn't be changing these things. Therefore, why do we allow ourselves to do? Transactional updates, I mentioned sort of Atomic being the first place I really saw this, but CoreOS does the same thing. And that this is around being able to change everything at once. Rather than having sort of versions of hundreds of packages, actually having a version, like a hash of the entire file system. And being able to transactionally change that, often by sort of actually swap it, basically loading another one and then rebooting into the new one. So then you can roll back the entire thing, which is interesting. And containers are ending up as a sort of a primitive as well. There's lots of different, some are massively focusing on that. Others, it's just there, but it's a primitive. It's one of the things that can be assumed that they're going to do well. I'd sort of argue that at least for some of this, we've seen it before. And some of this comes down to the hype around containers wouldn't probably be as hypey if we just called them type 2 hypervisors rather than container runtimes. Containers just sounds better. And we can have metaphors like shipping containers and makes better slides. Type 2 hypervisor sounds boring. But the type 1 hypervisors were the sort of idea of well, there's hardware, there's a hypervisor, you're running a virtual machine on top. And we went through that. If people are old enough, we lived through that. We saw the sort of emergence of ESX, ESXi, Zen Server, and others, and they thought more the commercial stuff. You've got KVM as well and whatnot. The idea of the type 2 hypervisor is that it's often sort of described as hosted. Yes, you're running some hardware. Yes, you're running the OS. You've got that hypervisor, and you've got an OS on top. So we've got another OS in the middle. And that, if you ignore the word hypervisor from a certain point of view, that's what containers are doing. I think we can argue that we've seen some of this before. And what plays out differently and what plays out the same is interesting. And one of the things you can definitely see here is in the sort of commercial part of this, where companies and startups are trying to get in here. Everyone wants to be the VMware of containers. If you don't know why, go look at VMware's market cap. So there's some stuff happening on the internet. There's a bunch of smart people doing a bunch of interesting things. Everything's got good logos. There's a bunch of money there. Something's definitely happening. So the question there then is why? Like, why is there this interest? Why are we, like, as a community, investing like people hours in this stuff? I think part of it is actually for like we're running increasingly homogeneous workloads, and by that I mean most people in this room will be running most of their infrastructure to run like things that look like web apps, that probably talk to other things that look like web apps, that might talk to other things that look like web apps, that might talk to other things that talk to the file system. Like not everyone, and not for everyone's entire estate, but actually an increasing percentage of the number of servers we run are dealing with that sort of workload. Like the number of machines running your printers is now sort of a smaller bit, and you'll have some CRM and there'll be some IT stuff. But the number of servers we're using for sort of web scale infrastructure is just massively more. And I think that's true of not just individual organizations. I think it's true of most people running most stuff. Another thing is actually security's front page news, obviously for all of the wrong reasons. But that's driving interest in like underlying problems, fundamentals, and ultimately money interest. From interest comes the option to make money, which comes funding. Like security is now something that is in like boardroom conversations, like computer security, much more than it was. People often say, rightly or wrongly, the sort of like, I just want somewhere to run my containers. Like, can't someone do that for me? There's also like the sort of size as a proxy for complexity, and it's sort of somewhat of a joke question there, but like who in the well actually no, let's make it a real question. Who in the room can name the 184 default packages that you get when you install Ubuntu? Like hands up. And like I will give someone like a slot of my talk if they can come up and do it. Like, who knows all the processes that would be running if right now you booted a CentOS machine? Like, this stuff's got out of hand. Like, we're running more software that we just don't understand. It's not about that we didn't write it. We didn't be writing everything ourselves. But we're running software that is just more complicated than we can understand. And this is an audience that is self-selected to come along to an operability conference in a tech center. Like, we can't do this. Like, no one else can do it either. I was super happy that the Force 12 talk yesterday, like a big part of it was talking about utilization. So I don't have to rant here about no one talking about utilization. But utilization matters massively. Virtually no one in like startup-y crowds cares. And then large organizations will pay any amount of money to make their utilization better. Like, there's a nice disconnect there. And we're increasingly interacting with higher level abstractions anyway. And one of the reasons why you might not be able to name those packages is you might not have even installed a package manually for a while. You might be dealing with something at a higher level. Increasingly, we'll see people who are like down at the operating system level, and people who are operators. They're in this room. They're part of our clan. They're part of our community. Who aren't. We'd seen that, and I think getting snobby about that is a mistake. We'd seen the same thing with AWS cycles, and people, oh, those people have never been into a data center. And it's like, have you seen the size of the AWS APIs? Like, they haven't got time to go to a data center. So that's sort of like the context, and hopefully people are sort of nodding, going like, yeah, like that's sort of, well, there's this stuff happening. This is why it's happening. But taking a sort of step sideways a little bit on some of that, like why. Let's go through a bit of a brief history of like infrastructure stacks. And I'd put once upon a time and sort of saying, well, actually, we had some hardware, and we put an operating system on it, and we ran an application, and that's how Etsy run. So, once upon a time, unless you're Ben. your application probably needs a runtime, and like you could get into too many stacks here for various different reasons. But we'll at least sort of say, well, you want hardware, you want some hardware in your operating system runtime. The problem is hardware is expensive, especially when most people are doing this, and so you run many applications on your hardware. The problem there is that those applications start having fights, whether for resources or for like with data, or because the people programming them hate each other. And virtualization came along and gave us another option. No longer did you have to have either this sort of model of everything running amok and destroying everything, or this, which was expensive. You could sort of have, you could introduce virtual machines. You could isolate things, but we're adding a sort of another operating system here. And we can run multiple virtual machines, and they're separated from each other. Notably, each with their own copy of the operating system. And so we're starting to make it more expensive again. But the overhead of virtualization turns out to be expensive. Who'd have thought it? And so we start running multiple applications in some of our VMs. So like we've basically just got the same problems we had before at 2 levels of the stack. Which gives us options for different things, which is the point. It's not that those problems are problems in every case. We've now got options. Options are good. I heard you like containers, so I put some containers in your VMs on your hypervisor. And we ran a bunch of those. And my applications actually don't work without an operating system. So we put an operating system inside our containers because it seemed like a good idea. But hey, we can run different operating systems in different containers on top of our operating system, on top of our hypervisor. Like, who's got to this stage? Don't do this. And sort of cool folks on the internet will tell you to just use static binaries and scratch containers, and you can make this a bit simpler. So, like, we don't need that operating system actually, because like the container is running on an operating system; it can bleed through. But this requires retooling everything. So yes, if you're a brand new startup, maybe you're using a language that can output static binaries. Maybe you're a really, really old company and you're using a language that can output static binaries. Everyone in between has lots of code written in things that can't output static binaries, which is a shame, but true. And maybe you don't need virtualization guarantees and everything can talk to everything else, and you can run your containers and your operating system on some bare metal. And at some point, you'll realize you do need some isolation guarantees, and you go back to that anyway. So, and that's where we've got to. And ultimately, we've gone from that, which is nice, understandable, lovely, and to this sort of big. And we could add more layers in here to make it worse. I'm limited here by the slide, not by the insanity of our infrastructure. This is not a good. This is not. My posit is that this is not a good place to be in for what we want to do, which is run systems that work. If you want to play with technology, good place to be. If you want to run systems that work, maybe not. So, what if there was no operating system above the hypervisor? Take that as a hypothetical question. What would happen? So it turns out that actually academics are awesome and often think about things ahead of time. They just don't tell anyone. And there's been this sort of actually quite a lot of academic research and building stuff work going on around this concept of unikernels. Who in the room's heard of unikernels? Good bunch of hands. Who's run one? Andrew and Milosh. Yeah, everyone's heard them, but part of it is this is to an extent research. So read the paper, Unikernels are virtual library operating systems. It's worth having a look at. But this sort of ends up looking like this. The idea being that well, yes, you've got some hardware, yes, you've got a hypervisor, but everything else is just that unikernel. What you're doing is you're taking your application, that your code, your business valuable thing, and you're compiling that down to a kernel. You're not running it in a container, which has an operating system inside it, which is running in a VM, which has an operating system behind it. User space and kernel space are one. Like, your application just gets compiled down. It is just one single thing we can ship around that can be run on top of our fabric. One of the things there is that we can include only the capabilities, only the libraries that we need. So, like, find me a Linux OS that doesn't have shell. Like, finding one without bash is hard enough. Like, well, you could remove it, but like, there's probably still shell. Does Linux work without shell? Like, you end up in this spiral of doom where it's like, how many packages can you remove from your Linux operating system before it stops booting? I'll come back to that in a bit. The idea here is that you're opting into everything. Everything is explicit. You're saying what you want, and including that with your application and compiling it down into a single thing. There's a whole bunch of interesting other properties as well. And we don't throw away the hypervisor guarantees. Hypervisors are amazing. Like, containers are the new hotness. Go back further enough, hypervisors, like, virtualization was the new hotness. Like, nothing really changes. But hypervisors, because they've been around longer, a lot of the stuff that hypervisors do has ended up in hardware. The whole virtualization is slow, was true when it was all in software, but a bunch of this is in hardware now, and a bunch of it's fairly fast. It does provide isolation guarantees that containers don't. If people want a demo of like someone breaking out of one container into another one, ask Ben. He's probably got lots. You've got a massively smaller attack surface. That whole how many processes are running, how many packages have you got in your operating system. The point here is that you explicitly know because you pulled them in, you chose them. So you're not running software that you don't need to be running. And you can argue that software's been around for ages, and like what could possibly be wrong with Bash and OpenSSL, and then like, oh God, like flashbacks, and then you go like, all right, I understand why we want smaller attack surfaces. We're just running less code. General purpose operating systems are general purpose. They can do anything for everyone, and they're huge. Again, back to the whole, actually, we don't need most of that. Our workloads look the same. We can enforce a bunch of immutability stuff here. Again, this is compiling our application down to something we run. Most of the people talking about immutable infrastructure have infrastructure with like writable file systems and SSH enabled. It's like, your definition of immutable and mine is different. We can enforce it because it's a property of the system. No default remote access is sort of another thing that falls out. It's sort of the promise of containers, but without needing to pretend the intermediary OS doesn't exist. It's sort of that, Heroku is amazing. You get to interact with this high-level API. Everything just works until it doesn't, and then it's like, wait a minute, there's an iceberg underneath. Imagine if the iceberg didn't exist. We can sort of get there with some of these ideas. There are projects out there, again, not demos, and Mirage OS folks from Cambridge is basically re-implementing the world in OCaml. The HalVM people are re-implementing the world in Haskell. This is obviously starting up to some sort of massive Cambridge fight between the Haskell people and the OCaml people, which is entertaining because I live in Cambridge. The rump kernel stuff is interesting, partly because it's a path to run existing POSIX software in this model rather than having to potentially re-implement everything. So they've demonstrated running Nginx with PHP applications in this model in a Unikernel. Ling is sort of the Erlang on Zen. Again, taking Erlang or Elixir if you prefer languages that are not quite as crazy as Erlang, and compiling them down into Unikernels. So there's a bunch of projects. A lot of this is either research or it's spinning out of research. It's not go home and run this now, but partly I'm wanting to talk about the sort of bigger picture stuff. I've written a bunch of posts that's sort of interesting probably to this sort of operations-focused crowd recently, partly about the security implications, partly about operational challenges. And that's sort of what I'm wanting to come on to. It's sort of, well, what does that mean for operators? What, like, if this were the world we lived in, what would that world look like? Again, this is based a little bit on speculation, talking to other people who are speculating, and playing around. But that's partly down to the fact that this stuff is research projects, or it looks a lot like how sort of someone like Google runs. And I think part of it is the hypervisor becomes that platform. And you do end up with that separation, whether that's a separate team running that, whether that's a separate company running that as a service. But what those interfaces to the hypervisor are is sort of a different question, and I think a potentially unsolved one. It's sort of like, how many AWS users know how to run Zen? I would argue not very many at all. Bridget and both other people. But as a percentage, it's tiny. Because you don't need to understand one to do the other. There is a clear interface. You know which side you live on. I think this happened with sort of Type 1 hypervisors, and I think we'll just see it with this new class of I just want somewhere to run my containers. In large organizations, there will be a team that runs the VMware stuff, so everyone else can get on with their job on top of it. In startup land, it's, well, Amazon are running Zen for me, therefore I don't need to do. I think we'll see the same thing with the sort of, whether it's that container layer or whether it's moving further forward to running things like Unikernels. What that means is that everything else is an application. Everything. It's there is that platform, then there's everything else. So that means things like firewalls, things that we think of as part of our operating system that we get for free. It's all software. But we have this sort of weird disconnect where it's like, that's part of the OS, that's not part of the OS. It's like, how do you install both of them? Oh, they're both debs. Why is one part of the OS and one not? Oh, well, they were all written by us and they were all written by someone else. It's like, is that a good way of thinking? It's like the operating system is stuff written by other people. And then you go like, is MySQL the operating system? And you go like, no. Is Rails? No. And it gets confusing. We have this idea that there's the operating system and others and our code, and it's fiction. Everything becomes an application explicitly in this model. I think this sort of already is the case. We're just really bad at thinking about it like that. So we don't then make the software fit this model. What would it be like if we chose the firewall? What about proxies as something that we're building? Again, we're moving towards that sort of everything is discrete, small, single Lego blocks. What about network switches? What about intrusion detection as an application? Something that you can just take and fit into your request pipeline. Remote access isn't suddenly something that is just built into all of our servers that we should never log into and will never use, but hey, someone on the internet can log into them. It's something that we explicitly include into our stack in a specific place as an application that has the characteristics that we want. So I think part of that is that everyone not running the hypervisor becomes an application developer. What being an application developer in that world means versus what it does today, I think changes. But I think that's where we're heading. At least for systems like this, non-general purpose systems. But I think actually the non-general purpose systems for this sort of large scale out stuff will be the majority rather than the other way around. One of the things that I think we need to get there. I think this is a better world, but one of the things we need to get there is standards. And that's probably both in terms of big letter standards that people don't understand and freak out about, but also just general agreement. I think there's a lot about how code is built and how open source has sort of evolved that is sort of, and the ease of which, I mean, like, I have a desktop supercomputer, like, that's tiny. Like, we have languages that allow me to write pretty much anything pretty quickly, at least to the point where it works, sort of, on my own. I no longer need a team of people in a massive computer, meaning that it's really easy to get prototypes out there. And we sort of probably spend too much time all prototyping the same thing, brackets. Who's built a PaaS in Docker? Because you could. It's that too much of that, like, just enough prototyping, like, sucks up all the time for us to spend, like, agreeing on hard stuff. So getting around sort of platforms, whether it's these or others, getting around sort of like container standards, formats, like agreement, not because of the standards and formats, but because of the tools we can build once we have that agreement. I think like one of the things that came up in a bunch of the talks was that monitoring, was that principle of having applications that expose their data. I think that's great. Everyone should do that. If we all do that differently, like, we then have to build the next set of applications, like, bespoke as well. So not only do you need to, like, export data, we need to agree what that data looks like. There's some interesting things here that have sort of evolved. I mentioned sort of like de facto standards. StatsD, I would argue, is a pretty good de facto standard at this point. Like, the in the sense that actually not only is the StatsD implementation, there's a bunch of other open source implementations, but also a whole bunch of the monitoring as a software as a service products now consume this because they know people can send it to them. So, like, yay for de facto standards. There's some attempts around sort of the metrics 2.0 spec and discussions there around, like, what the format of time series metrics might look like. Like, more of this stuff is needed. And sort of a call to action to people in the room, really, sort of, I guess, publish more schemas on GitHub and fewer, like, incompatible duplicate implementations of stuff. Like, yes, we should write more code. Like, more code is definitely going to solve all possible problems. But actually, like, publishing schemas, publishing, like, things that we can maybe come to agreement on might be a better use of some of our time. I think whether we collectively or others then get to, like, actual proper standards is a super interesting question for the future. But, like, first maybe start sharing, like, schemas. So infrastructure, like, to me, in this sort of potential future, well, it is code. It's not just that. Obviously, we talk a lot about sort of infrastructure as code. I think to an extent, that often ends up looking like infrastructure from code. You have code, you run code, you end up with infrastructure. And yes, we public labs, but others as well, do things to, like, sort of synchronize that a bit. But ultimately, you're generating your infrastructure. Your infrastructure results from code. It isn't actually the code you're writing. I think in this model, it is actually, like, the code that you're writing, that you're choosing to compile into your application. It is yours. It's the much clearer sort of ownership. That infrastructure is code. But there's also the sort of, I guess, part of that thread is that the algorithms become important. Again, like, harking back to the Force 12 conversation about sort of schedulers. Schedulers are super on vogue at the moment in certain parts of the internet, and they're coming to a part of the internet near you soon. We just had that conversation outside. I agree. But things like back pressure as well has been something that's been mentioned. Autoscaling has been mentioned a few times. That these sort of things are algorithmically driven, and actually we could probably have more implementations than, like, actual algorithms. And we sort of need to get better at separating those two things out. If you're thinking this is sounding like computer science, it is. Sorry. I'm not even a computer scientist. It's all gone horribly wrong. Composition and configuration becomes really important in this world. In that, like, we have these units of things, but we need to, and we can do some of this dynamically with like the right scheduling. But the scheduler needs inputs both probably from the dynamic live system, but also from us about choices that we make. So I think configuration and sort of composition become a big part of this. And I really think that static data won't be enough to save us in this world. It is about code. It is about learning to program. And I've sort of put like, this time we mean it. I think like, the bits at the bottom are like, actually, we need safer programming languages. We need types. We need to, like if we're building sort of if we're re-implementing some of the fundamentals, like some of the network device stuff, like the things that actually tie everything together, we need to just do a better job this time around. I think like if this happens, if this is where we're going, and I think this is where we should go, it's a revolution, not evolution. I think the distance between sort of like the infrastructures that we run today that work, they do okay. I think there's some problems in the future where we can't get over, but like I think the gap will be massive. The distance between old and new will be huge. I think it will be much bigger moving between the sort of these two paradigms than moving from like a Linux shop to a Windows shop. Like the tools are slightly different, and one side slightly has a thing for GUIs, and one has the like sadistic sort of masochistic sort of pleasure in CLI interfaces. Like, but they're both general purpose operating systems. They're both running a whole bunch of stuff. They're both sort of like mutating towards the same sorts of areas. Like they're fixing the same problems. I think a world where everything's applications, where like we've stripped away most stuff, is much more different than moving between any of those. It's not really about the tools. I think that like we'll do the tools anyway. It's about the model of interaction. It's about the skills required to operate in that new world. And I think that's sort of this isn't happening tomorrow. This is going to happen over a period of time. It's going to happen during our career. And I think there's that question of individually, collectively, do we want to see this happen? If we do, like, which side do you want to be on? Where do you want to be? Because I think that, like, hey, coming back to the AIX point, like, people will still be running RHEL 5 in 20 years. Like, that job is not going away. I think, like, one of the drivers, one of the big things here is, like, we need to fix our technology. I think the security challenge in particular, the complexity challenge is sort of there, but actually that's just the limit on how much large companies can make without paying for as many people as they need, like basically. We'll destroy the planet with energy, but that's, again, like, that's generations away. That's cool. The security challenge is real, and it's now and getting, like, better or worse depending on which side of that you're on. If we as technologists don't, like, actually look to address this, like, fundamentally, and coming back to that quote of, like, from 40 years ago, I don't think the way we're working today, like, we're no further forward there, and that was nearer the start of computing than, like, that distance of time. I think, like, laws and policy and government and politicians will fix this problem for us, and that will probably not actually fix the problem. It will definitely make our jobs less interesting. Like, let's wager. I was joking earlier that maybe someone will, like, outlaw WordPress, which you could argue might make our lives better, but they'll probably ban lots and lots of other stuff, like sending you to prison for, like, writing software and running your own software without it being signed by someone from the government. Like, yay, dystopian future. But remember that, like, well, Blade Runner is a movie about the government running around fixing bugs in software. Like, we could create this world unwittingly by simply just continuing down the road we're on. There's better ways, I think. It's a thing really, like, we still have fundamental problems that date back more than 40 years about how we build and run systems. I don't think we're going to find a solution like just by doing it harder. But I think we can build like better infrastructure. I just think doing so might mean going down different paths, like taking a step back or taking several steps back to go forward. I think we know the interesting thing is I think we know, even with the technology we have, we know many of the patterns we want. I think the talks today and yesterday have picked up on a bunch of these things, and whether it's exposing metrics, whether it's logging, we sort of know the model we want, and we end up sort of stripping down our operating systems and chiseling off bits that we're sort of, or ignoring things that, well, we're not using that, so what could possibly go wrong about it being there? But we're working backwards. We're not actually driving something forward. I think fundamentally this means throwing away things that we care about, like individually, professionally, like as a community, and getting the wording this is right because it's been filmed. But what would you say if I said we don't need Linux for the general case? Who in the room is everyone joked at the Windows thing, but who's invested quite a bit of time in Linux? Who has books that are at least this thick about Linux at home? Who knows all the arguments to PS? It's worth a try. Yeah, Bridget knows all the arguments to tar, and you can test her on them later. We know an awful lot of arcane information that is allowing us to do our job today. I posit that a load of that time might have been wasted on an evolutionary path that was a bad idea 40 years ago. Milosh said, "Don't make this talk too depressing." But again, I think we can make better infrastructure, fundamentally, not a bit better, not the incremental, the large incremental improvements that we've seen over the last 5, 10 years, whatever, that we're seeing every year. I think we can make a sea change. I think we can jump far ahead. But doing so means collaborating on hard problems rather than marveling about how easy it is to build your own Docker paths. People stop it, please. Well, yeah, that's the problem. So hopefully that was entertaining enough that you don't want to lynch me for saying we're all doomed. Because I don't think we are. I just think we can collectively get ourselves out of this hole. And any questions I will happily take.
After the end.
Oh.
Yes, we need to finish on schedule.
All right.
And then all the time you want for question outside. Thank you very much.